an evolution of cross-industry collaborations organized by EU Chamber's ICT Committee. This is the first webinar that is under this committee. Before I introduce the dignitaries, may I request all our attendees to kindly post their questions only in the Q&A box. We have with us Mr. Ashank Desai, the chairman of ICT Committee. He is the founder and former chairman of Mastek Limited. He is one of the founder members and past chairman of NASSCOM and has been felicitated by Prime Minister Shri Narendra Modi for his contribution to NASSCOM and IT industry for the last 25 years. We also have with us Mr. Durjoy Patranabish, the member of ICT Committee of the Chamber. He has more than 23 years of experience, rich experience in diverse services. He is currently the Vice President and Head of Global Business of Tiger Analytics India LLP. Mr. Desai, may I request you to kindly give the welcome remarks. Over to you, sir.
Ashank, you may be speaking on mute.
Thanks, Anvita, for the introduction. Welcome to all the participants. Good afternoon. I'm very pleased to really launch our program today of ICT Committee of EU India Chambers. We thought through this program a few months ago. We have with us, of course, the panelists and our Vice Chairman Joseph Shields is also with us, and Durjoy, who is also part of our committee. So he is driving this particular seminar. We have, of course, all the panelists which will be introduced, I'm sure, by moderator. All of them come from a very interesting background, which is required for Industry 4.0, I suppose. And what we thought about Industry 4.0 was in this fashion, that if we have to do something for our ICT committee, it should help our members. And when I mean members, I mean really end users, as we call them in IT industry, really. Because they are our customers in some way. And whatever we want to do is going to be focused around them. And we see in EU, for example, large manufacturing organizations from all over EU countries. And I think some of them are participating here, I'm sure. And we thought that if we can add some value to their thoughts, value to their strategies, it will be a great thing to do for us as ICT committee. So with that in mind, really, we have this Industry 4.0 and collaborations. I am not going to speak about it. I think all the experts are here. But coming from IT industry, I can't resist from saying few things about 4.0. So as there are many definitions of 4.0, of course, and there are as many definitions as there are participants maybe at one level. But one way to define it is kind of technologies or systems that are converging to make it happen. And there are 10 of them, 9 of them, like robotics is one, additive manufacturing, augmented reality, simulation, horizontal vertical integration, IoT, cloud, cybersecurity, and big data. I think I am in IT industry last 35 years. I have not seen convergence of such technologies together, which is changing everything in our industry beyond manufacturing. But here it is about manufacturing, and I can see the importance. I want to quickly talk about horizontal and vertical integration, which is really the key to the whole thing. And horizontal and vertical integration is partly something that we'll talk about when we talk of industry collaborations at one level. See, horizontal integration is across from sensors to enterprise level, ERP. That's the kind of integration that IT makes it happen. But what's happening is it is bringing horizontal integration of right from supplier or even product designer to the customer. And I think this is a whole new world. So I'll stop here. I'm quite excited to hear all these experts who are going to be here. And I hand over to Durjoy again to move it ahead.
Thanks, Ashank. Thanks for the opening remarks. So welcome once again. We have a fairly diverse and fairly, well-experienced panelist with us today. So privileged to be privileged to be part of this panel discussion and having them here. So I'll probably introduce the panelist first, and then probably we'll go, one by one, and probably get their perspective in terms of Industry 4.0. Our first panelist is, Mr. Vinayak. Vinayak is a partner at Ernst & Young, primarily representing the heavy industry and works across the supply chain and operations. And he's been, Economic Times Young Leader in 2012. So he brings in a lot of perspective from different industry across, for Industry 4.0. So once again, welcome to Vinayak. Our second panelist is Dr. Natarajan. He is part of the R&D team at Reliance Industry, comes with strong research background. Past experience has been working with the John Welch Technology Center with GE. Himself, in that sense, bringing the perspective of how Industry 4.0 and R&D are working in collaboration together, how one is feeding into the other. So welcome, Dr. Natarajan. Our third panelist is Mr. Hariharan. He is Vice President at Motherson Sumi Infotech and Design Limited. Obviously, tons of experience behind him, a lot of experience within Motherson Sumi as well as working with various clients across industry. So that's the perspective we'll get from him in terms of how Motherson Sumi has not only rediscovered itself, but also helping its clients to actually embark on the Industry 4.0 journey. So welcome, Hariharan. My final panelist is Mr. Rangarathan. Ranga, as we call him, comes with tons of experience at Honeywell, currently part of the Honeywell team. Ranga's perspective here will be primarily from a platform standpoint, how various platforms that Honeywell is building and versus industry wide, how is it being applied across different industry functions and different processes. So welcome, Dr. Hariharan. Good to have you here. With that, I will primarily kick off the panel discussion. The format is primarily, initially we will go around the table with each of the panelists, giving their initial perspective, and then post that we will kind of moderate and have a facilitated discussion on some of the topics that gets discussed as part of the initial commentary by each one of the panelists. With that, I will invite Vinayak to talk about his perspective, basically working from a consulting industry angle as he works with different industry, works with different processes. What are the I would say trends, challenges that he encounters as he is collaborating with different clients and different industry? Over to you, Vinayak.
Thanks a lot, Durjoy. So like the title slide says, that this is a consultant's perspective. This is a lens that as a consultant we use. Typically, we try and analyze the market. We see how the market is evolving. We see what are the challenges that this evolution is posing, or what are the risks that the evolution is posing. How prepared are we to deal with those challenges, mitigate those challenges, and how technology is then playing a role in addressing those challenges. That's what I'm going to be sharing today with you all, along with a few case studies of how technology has been embraced by different sectors and the efficiencies to productivity improvements have been driven across sectors. So if I may request, yes. Okay, so broadly, what we see on this slide is the current landscape of the Indian manufacturing sector, which is specifically when we talk about smart manufacturing, it is likely to grow from the current USD around $214 billion to around $385 billion in the next 4 years, which is a growth rate of around 12.4%. Now, this growth is driven by the growth which itself is happening in manufacturing, the push by the government on manufacturing, the contribution of manufacturing as a sector to the overall GDP, and the likely growth is that by 2025, it should touch a $1 trillion number. And also the consumption, which is going up primarily from the middle class, the rising middle class or the growing middle class population that's there, that's driving this change. Secondly, the usage of IIoT platforms, which currently is estimated at around 10%, that is likely to go up to 50% by the industrial enterprises in the next 4 years. So this is a very, very rapid adoption which is being driven. This is again driven by the accessibility of the digital solutions that these companies have, the falling prices of the equipment, or specifically talking about the sensors, that is also driving adoption. And the maturity of the service providers to provide comprehensive solutions, that's also going up. Then smart factories, again, like I mentioned, that almost all types of factories or industries are embracing it. There is a very strong integration between IT and OT, which is driving the efficiencies in factories. That's also driving the growth of smart manufacturing. And finally, MSME, which traditionally has been considered to be a sector which is not very friendly towards technology, I'd say. Largely manual processes are driven in MSMEs. Here also we are seeing that with the complexity of the supply chains, the complexity of addressing the requirements of the markets enhancing or going up, MSME has also started embracing some of these technologies very effectively. Okay, if we can move to the next slide, please. Okay, while the slide has not come out well, it's not legible, but just to share with you that there are multiple challenges which the manufacturing sector experiences, which are around quality and safety, cost and productivity. Specifically on quality and safety, the ones that you're seeing in gray, dark gray, I think, sorry, the ones which are in white right now, safety and sustainability related, or the rejections or QC resolution related, or the material wastages. These are few challenges which are experienced on the shop floor. These are primarily driven by the operating conditions of the equipment, of the plant, of the machines. They are also driven by the faulty settings, which typically are there in the equipment and all. And also some bit of issues are related to planning and the scheduling. So all those challenges which are faced pose a safety threat on the shop floor, which again, a lot of these smart factory solutions are addressing. When we specifically talk about cost, there are multiple cost levers around which the challenges are experienced by companies, starting with the working capital costs, clearly the inventory and the waiting times and the lead times to service the demand of the shop floor. That's a challenge which is being faced, and stockouts not only has an impact on working capital, but also on the productivity of the plant. So that's a challenge that is faced. Energy cost is typically a very big cost element, or the major cost element in most manufacturing processes. Here, the wastages in energy consumption is again a big challenge, which is faced by the companies. There are challenges with respect to the recipes, which are again the consumption of material that's happening, which is eventually done keeping in mind the quality of the end product. So what should be the ideal consumption? What should be the recipe? So companies are grappling with those kind of challenges as well. And then there are labor productivity related challenges as well on cost front, which are experienced by companies. When we talk about productivity, finally, the productivity per se, that's where the consistency in production, the fluctuations that are there, the shutdowns which are experienced by the companies, or the changeover or setup times, which are again experienced by companies, primarily related to planning, inefficient scheduling, related to poor operating conditions, related to the wear and tear of machinery and equipment. These are some of the challenges which Smart Factory is trying to address in the overall manufacturing value chain. Okay, if we move on from here. Okay, now when we look at what is enabling the adoption of Smart Factory or the new age technologies, clearly COVID has helped the adoption to a large extent. So there is some silver lining that we can find in COVID. But the industry is or has been moving in this direction for a long time. Over the last 5-7 years, we are seeing that the adoption is going up. COVID has accelerated this adoption. A lot of many companies are now focusing on bringing in these digital technologies to manage the efficiencies of their processes and of their people. But one of the important aspects is the cost of sensors or the cost of equipment. It has reduced considerably over the last 15 to 20 years. So it has made sort of adoption affordable for companies. On an average, a typical sensor is costing close to around $50, which is 35 to 40 rupees. That's the cost of a sensor. So a lot of information can get collected through these sensors at a very cheap cost. That's also driving adoption. I had mentioned around IT and OT integration. This is again something which in the past, IT and OT, they always operated in silos. So all the information in SCADA, PLC, that remained in one bucket, and all the information in the ERP of an organization remained in the other bucket. Now these two buckets have come together. The information is used jointly, is being leveraged, the IT information being leveraged in OT decision making and OT information being leveraged in IT. So that's also driving adoption. Big data, both structured and unstructured big data, is being used quite effectively. And finally, the AI ML, which is where the real-time analysis of information, the new technologies or the advanced analytics platforms created using the artificial neural network science or the genetic algorithms, again, solving complex problems in the computers or on cloud. That's something which is again driving the adoption of these technologies. In terms of the decision variables across the value chain of operations, the decision variables are getting influenced, or I'd say that decision variables are driven using these technologies. In supply chain, specifically when we talk about procurement, rather than focusing on landed cost, now the total cost of ownership as a concept is driven in companies, where the impact of quality or the chemistry of material or the physical properties of the material that is being considered, the impact of that on the productivity, on the operations consumption is being considered in the procurement decisions. From a consumption point of view, again, the recipe point that I made, again, the chemistry, the operating parameters, the physical properties, how are they driving the right chemistry, not only of the raw material, but the raw material with the fuel or with the consumables. All these aspects are taken into consideration. When it comes to production specifically, all the operating parameters get influenced by the material quality, get influenced by the design of the plant or the equipment, and get influenced by the age. So here again, the interplay of different variables is driving the decision making on the shop floor in terms of how the operating parameters should be set. And finally, in terms of the OE improvement, the efficiency improvement of plant and machinery, that's where again advanced analytics is being used to drive action. And just to finally share a few examples, across industries, companies have embraced smart manufacturing. The first example is of a leading steel and power player, where they've created digital twins for their entire value chain of operations, from the primary manufacturing to the secondary manufacturing, from the blast furnace operations to the coke ovens to the final steel melting shops. They've adopted digital twin, where again the IT/OT integration is driving the consumption and the productivity and quality of the output. Aluminium industry, again, aluminium is energy intensive. So there the power cost reduction or the energy efficiency is being driven through smart factory solutions. The power sector here also, there are concepts around plan to fire, where what should be planned to be procured and how should it then be used in a boiler in terms of the coal quality, in terms of the quantity, the GCV, the ash content, the moisture, different aspects are being worked upon using some of these technologies. There's a world's largest cement producer has made few of its factories complete smart factories, where all decisions are driven using the new technologies or the digital solutions. Again, the efficiency improvement has been significant for them. The global tire manufacturer, the tobacco companies, they are working on improving the people productivity using smart factory solutions. So these are some of the examples of the adoption of smart factory in different sectors. The applications are there for FMCG, the applications are there in services sector also, not exactly factory, but the interplay of factory with the services. That's where the examples are there. So this is becoming the new normal, I would say. This is the way forward, and more companies are going to make this a part of their DNA going forward.
Thanks, Vinayak. That's interesting. You know, I picked up some 3 or 4 key themes, right? One is the affordability of sensors. It's not only the affordability of sensors, but we see affordability of the computing power, affordability of the whole data storage that's enabling this, and the whole thing about the collaboration between IT and OT. We at Tiger, we are seeing more and more operations people and manufacturing people asking for solutions rather than just being driven through IT. And the final piece, you talked about the procurement to consumption to manufacturing to efficiency. I want to bring in Dr. Natarajan because he will capture the R&D piece, which probably is in some way runs across procurement till manufacturing. So with that, I will invite Dr. Natarajan to give his perspective as how some of these industry 4.0 themes and mechanisms are being put to place in R&D, and how does it go back or feed into the overall multi-process manufacturing at Reliance. Over to you, Dr. Natarajan.
Yeah, thank you, Mr. Durjoy. And we just heard from Vinayak on the trends and challenges in the industry. And of course, the perspective that I want to bring here is more from that of a consumer or a customer perspective of implementing IR4 technologies with a greater emphasis on artificial intelligence-based technologies. Good afternoon, ladies and gentlemen. I come from Reliance Industries Limited, and Reliance, as you all know, is a large organization with many different business units and with many employees. Just want to say here that the views expressed by me in this webinar are my personal views and do not represent the views of Reliance Industries Limited. We are living in the age of Industry 4 technologies, and while I will talk to you about some of the challenges that we have in R&D, I'll come to that, what you see in the slide. But before that, I want to take you to the kind of work that we are in. The computers are getting good at playing games, driving cars. We have the voice assistants like Alexa, Siri, because of advances in natural language processing and speech recognition. There is everyday interactions. A lot of that are going digital and smart. And of course, AI data science has impacted many areas, from banking, finance, retail, etc. And of course, R&D is no exception. But coming to science and R&D, which is a bigger focus for me here, AI has made remarkable progress. I just want to give a couple of examples here. For example, if you wanted to look at, predicting protein structures in biology from amino acid sequences, DeepMind AlphaFold can predict these structures. And from a scientific sense, this is a 50-year-old problem. And the latest system, of course, the AlphaFold system achieves the structure prediction within an error of 1.6 angstroms, which is acceptable. And 1 angstrom is about 10⁻⁸ centimeters. In the natural language processing, I mean, let's look at another example from chemistry. Google created this word-to-vec algorithm. And analogously, the Stanford scientists created something called atom-to-vec on similar ideas. And they actually used it to construct the periodic table that we are all familiar with in chemistry, based on the relationship between elements with the data from chemical compounds. So there are many more instances and applications in the areas of catalysis, material informatics, polymer science, computational biology, and so on. But of course, for a bigger focus, let me come to the challenges for applying AI and data science in R&D. When I say R&D, please note that my observations are pertaining to the R&D in the chemical process industry. What I have done on the slide that you see there is I have divided that broadly into 4 categories: data, metrics, models, and domain knowledge. Now, data, when we look at some of the challenges related to the data in R&D and data in other segments like finance or retail, it would be very striking that there would be relatively very less data in R&D compared to the other, in a relative sense, compared to the other segments. And the reason for that is, areas like retail or digital, and of course, because of their B2C nature, they also have a lot of volume. Whereas the data in R&D comes out of physical experiments, which can be very expensive and time consuming. A single experiment can take weeks. Of course, we use some strategies to increase the availability of data, such as digitization, high throughput experimentation, using AI to convert qualitative to quantitative data, augmenting with the data from different sources, including literature, public databases, etc. Of course, most scientists know that data from public literature may not be comprehensively available for a consistent set of parameters or conditions. We also do look at generation of synthetic data through fundamental AI models. AI models and fundamental models are also used. And there are some techniques like sequential learning, which are an iterative data-driven method for exploring a parameter space when doing experiments. One silver lining, which also Mr. Vinayak touched upon, is as the cost of sensors coming down and the growth of IoT technologies, it can lead to the greater availability of data for R&D as well. And the next one I want to talk about are the metrics. In traditional AI/ML applications, some relatively simple metrics may be involved. And again, in the case of R&D, what happens is we have to look at an ecosystem of metrics. For example, we can use these technologies to develop a new material or a new catalyst. But for it to be successful, it also needs to be safe, economical, scalable, environmentally friendly, etc. So it's not just a single metric, but for us, we need to think of a problem in a very holistic sense. And what it also means is we need to collaborate with the right partners from the very beginning, and that's essential. Okay. When we talk about models, systems in R&D are different in the sense, are governed by fundamental laws and principles of physics, chemistry, and biology. So this fundamental knowledge should be exploited. Of course, there are current trends in what are called hybrid modeling, which include the creation of implementation of digital twins, which also Mr. Vinayak mentioned. They leverage the best of both AI modeling and available fundamental scientific knowledge. And of course, typical black box type AI models, although they are useful, they will have limited appeal in R&D areas because it also should include, the fundamental scientific knowledge. And of course, the move towards explainable AI is very promising, when we are looking at domains like R&D. And of course, there is a lot of validation that would be required in terms of thinking about models for R&D, because they are implemented in digital physical systems and of course must pass stringent validation requirements before something new is implemented. Now, So the point about domain knowledge, in R&D, it is not enough to solve a problem in the sense that we are working on something. We have something working, but more often we need to understand why it is working, or sometimes why not. So it is not just the know-how that is important, but it is also about know why. And the results will have to make sense scientifically. And in fact, if you compare the availability of domain knowledge in R&D versus some other areas, there is a very high availability of domain knowledge as compared to the data that is available, a proportion of data that's available in R&D. And it's a differentiator with respect to domains such as finance or retail. So the know why requirement, in fact, might affect choice of some models for critical applications, such as the deep learning neural network models and so on. So in these few minutes, I hope I have given you an understanding of the unique challenges that would greet such technologies in domains such as R&D. However, having said that, I mean, AI and ML and other IR4 technologies are indeed making greater inroads in the R&D domain and are becoming successful. And we would continue to see this happen as all these technologies evolve. Thank you.
Thanks, Dr. Natarajan. I know that's fairly insightful, very different perspective, coming from basically how is, all the design activities take place before it gets fed into the industry. I'll now invite, Mr. Hariharan to give his perspective. He comes from a background where they have evolved their organization from Industry 4.0, as well as helping their clients with Industry 4.0. So over to you, Hariharan. Give a perspective about how the journey has been. What are the kind of pitfalls you have encountered, and what steps you have taken to, circumvent that in order to come to where you are in terms of your maturity.
Thanks, Dan, Durjoy, and thanks to my co-panelists, who have, initially given the base and given their views as well on first the trends, and also Mr. Natarajan talking about how it is implemented within Reliance, right? Gentlemen, gentlemen and ladies, I'm Hariharan Ramakrishnan, Global Head of Digital and Analytics Services at Mind. For us, first of all, let me say Industry 4.0 was coined by Hendrik von Schiele as a German strategic initiative. And the 4.0 revolution itself introduced us to the man meets machine world, where technology and people are not distinct per se. And just if you could go to the next slide, please. The next slide after this. Yeah. So in the Motherson Group, this is one of the most trusted groups and fastest growing specialized manufacturing companies for OEMs. We're also in the top 20 largest automotive suppliers worldwide, with a global workforce strength of 135,000 and operating in 41 locations across the globe. And we've also made it to the Forbes Global 2000 list. Next. Our company was basically founded in 1975 in Delhi as a family business, and with wiring harness as the main business between a mother and a son. And we established a strong foothold in India in the 90s, starting with, being, in fact, in the 80s with providing the wiring harness to Maruti and enabling them, having a first impression of made in India there, where, the wiring harnesses were made in India, right? And then over the last 2 decades, since the 90s, we've grown and created a strong foothold, within the industry, through acquisitions, through joint ventures, and through our organic, relationship focus with our customers, who are essentially OEMs. And since 2010, with a large acquisition and strategic positioning, we've emerged as one of the major global players in manufacturing space. And the reason why I'm, emphasizing on this, inorganic so far is, something that will blow your mind out as to what exactly this entails when you actually go to create systems for this kind of a business. But before that, I also want to quickly give you a snapshot of what is the diversity, we are talking about here. If you could just go to the next slide. Our group strength today lies in our diversified business portfolio. Our solution capabilities today are in 10 major verticals shown on the slide. And working with a diverse group like ours, we can fulfill the need of any large diversified enterprise. But this diversity that we brought about for, disparity between systems, right? And if you go to the next slide, what we do at Motherson today, we are a truly digital enterprise in implementing Industry 4. We've been able to do that by empowering our past challenges. Back in 2013, our plan was to expand our footprints globally. And the initial constraints that we faced in 2013, when we looked at our roadmap, our current business, and all the disparity in systems that we've from the companies that we bought out, right? And we are looking at a group which is 200 plus companies with disparate systems, fragmented data, and problems across functions, like no visibility for production figures and data, downtime, significant scrap in injection molding, in paint line process, lack of predictive and preventive analysis to avoid exigencies, decentralized procurement systems, suppliers selling the same component to different companies at different rates, and no clear picture of the group's financial health at a top level, with no visibility on budgets and projection for each and every company and how it amalgamates on the top, and as well as pressure from auditors for coverage and red flag identification. Now, imagine this happening in a group with multiple entities and across different geographies, and manufacturing different components in different companies. Somewhere we are manufacturing reflectors, somewhere we are manufacturing wiring harness, somewhere we are manufacturing polymers, and so on and so forth. And in this, we had to create, we tried various things, right, to look at systems in the market which are available to cater to our needs. But frankly, there was none out there which could be one solution which would take care of all our needs. And hence, we decided at that point of time that we have to create our own. And therein, we introduced the Motherson Intelligence Framework first, which is a framework that provides actionable, intelligent insights that helps improve planning, analysis, and integration. Today, this Motherson Intelligence Framework, we call it MOTIF within the group. And we integrated finance, sales, spend modules globally across over 120 group companies already. And to have a holistic view of the health of the group and having a decentralized view of the spend data with dedicated view of suppliers, units, etc. The finance module that we created provides the group with a group-wide management reporting, budgeting, analysis, and the sales module within the group gives information on sales against each customer, against profit centers. And at the same time, with the audit module in place, the group was able to identify 40 million plus rupees in gaps due to the purchase of items at differential rates. Implementing the factory module additionally, we brought an improvement that led to asset utilization improvement by 10% and also reduction in scrap by 4%. Now, go to the next slide. And if you look at the snapshot of the variety of products that I've shown here, we call them products today because we're also positioning these outside the group. But essentially, these were solutions that we created within the group, which today, of course, help other enterprises to deal with any complications and handle unexpected high demands and cope with dynamic markets. Our solutions utilize technologies to make current manufacturing process smart, integrated, and connected. And many of the things that Vinayak spoke about, right, with respect to the issues that are faced in smart manufacturing, these are all being handled by these products today that we've created. And these include Motif Lakehouse, which is a blend of BI, the power of BI and data science coming together in a single platform for all the data needs. And it simplifies the data governance for us across the group with a single control point. Then we created Morango Ledger. Morango stands for Motherson Receive and Go, right? And this is a smart warehousing system that we created in-house which today is also blockchain enabled, which means data is immutable, and it also provides end-to-end traceability for us in real time, right from ordering the supplies to when the supplies come from the supplier to the warehouse, and thereafter within the factory as well, and also enabling this further with where it connects with the robots like cobots, copots, AGVs, etc., and as well as going further into the forward logistics and enabling us to track and trace right up to the distributor or even the customer if required. Then we created IDAX, which is an IoT-based ERP and machine agnostic system with real-time data acquisition and production monitoring capabilities, which basically captures data from any sensors that we have implemented. Of course, we have a company internally which also creates telematics. We have tooling solutions being created. We also have set of solutions which we call Robust, which has over 200 plus solutions, which include affordable robotics like collaborative bots, cooperative bots, and as well as assisted guided vehicles. And all these we're creating within the group. And also, these systems are all interconnected. So an IDAX, for example, is talking to the sensors which are in the machines. It's collecting data from there. It is also orchestrating the bots, the AGVs. It's sending the data to Motif for analysis, right? And then we also create a platform called Henkan, because we realize that when you have to interact with people who are taking decisions, we need to create solutions very quickly and in an agile manner, where they're able to use these applications to either input data or receive or gain access to data. Therefore, we created a rapid application development platform of our own called Henkan. And then, of course, Motif itself, which is a complete set of solutions, which I spoke about a little while back, around sales, spend, factory, audit, for the entire group wide, as well as, in HR as well and finance. So in all these, what we got is a unified view of our business, enabling on one side, the factory itself into a smart manufacturing model with Robust, Motif, IDAX, Morango Ledger, and Henkan, with Industry 4. The top 5 that I'm talking about are all Industry 4 solutions. And then with the finance solution from Motif, etc., the visibility of insights that we have across the group, that is what is enabling us today to have doubled our business over the last 5 years to $12 billion today in the group. And that's what is fueling our growth 3x in the group to $36 billion group in the next 5 years.
Thanks. Hari, I have to pause you. Yeah, we are going a bit over the time. So that's a great perspective in terms of how have you productized some of the solutions that you actually were consuming yourself, and therefore not only enabling yourself but also potentially enabling external clients. So and they are all connected, and that's I think where the power of multiplication will come in, right? Having a standalone system may give you tactical power and tactical benefits, but once you connect these systems, that's when some of these actually have 1.5x, 2x, 3x kind of effect on the overall end-to-end process and manufacturing side. So I'll probably invite with that Dr. Ranganathan here. He will bring in the perspective from a Honeywell standpoint in terms of platform play when it comes to industry, and in fact, basically, flows into from Mr. Hariharan, where he talked about some of those platforms that are homegrown, which is primarily to use it for own consumption and then become a more market leading platform. Whereas Dr. Ranganathan will probably talk about how Honeywell is basically leveraging Industry 4.0 and building new platforms for the larger industries. Over to you, Ranga.
Yeah, thanks. Thanks, Durjoy. I just I'll make sure that we have a few minutes left for questions. Honeywell has several businesses, but I'm today focusing on the continuous operations area, where we have a legacy of about 4 to 5 decades in the industrial automation. To do large projects to a lot of clients, including probably Reliance. Right. So one of the challenges, that we have embraced is to how do you adopt these technologies in a way that it evolves into over 4 to 5 decades of our approach to industrial automation. So if you see on the right side, in some sense, it is giving you the perspective of we are driving this whole automation towards an industrial autonomous operation. Now, it's not possible across all different industries, but where possible. Now, what do we mean by industrial autonomous operation? It is equivalent to like the way the cars today are, driven autonomously. It doesn't mean that the driver is taken out. Likewise here, it doesn't mean that the operator is taken out. So the evolution of Honeywell has been towards 3 important pillars, which is safety, reliability, and efficiency. So how do you continuously improve? So if you see here, in the late 1980s, in the early 1980s, we came up with the first DCS systems, Honeywell TDC, that became very popular and allowed the operators to take a 3x scope of work, more scope of work, basically improving his ability to do higher order works, apart from other digital benefits. Now, if you see in the late 90s or early 2000, because the compute power was going very high and ability to sense a lot of stuff and put sensors across, allowed the and also the openness architecture to have systems talk to each other, disparate systems like like competing companies like ABB or any other Emerson's, all allowed interoperability, allowed the software to really go to the next level of providing advanced controls and optimization that took the next level of step changes towards the safety, reliability, and efficiency. Now, if you see what we understood from our customers was that there was a 10x fold increase in the safety of the operations, though we were pushing all the limits that was happening, and the efficiency itself went very high. But then in all these things, all these softwares, and which are somewhere dependent on the model or some form of either the first principles or the gray box models, which Dr. Natarajan spoke about, is a life cycle kind of a activity. It's just not one time done. So that's when I think all the intelligent machine operations or predictive maintenance, all those that needs to be a continuous way of looking at it to improve, to keep it up to date, and still keep it as the models as relevant as reflecting the true behavior of the systems, whether it's machinery or the plant. So that's when these intelligent operations came up in a big way, where what we call it as digital twin was existing in this industry for a very long time, and largely it was offline, and then some aspects of online aspects came up for the digital twin. What digital twin could be simply called as a model, either from first principles or heuristics based on domain, or combinations with data. And then now the ML is helping us to update certain parameters to keep it tuned to the current scenarios. Now, if you look at these, as I go through this, the next step changes come really from these new technologies, which are cloud, AI, ML, and IoT. And Vinayak spoke about, Dr. Natarajan spoke about. But the way I think what we are seeing here is what is this step change bringing up? So each of these industrial revolution that happened brought in step change. How this step change is happening is within the plant or within the site, or we integrate few units. Then the perspective of looking at the larger units or across your businesses, it requires a lot more processing, either on the on-prem or at a different level. Now, investments such as these was prohibiting, and though concepts were floating around, how do you do plant-wide optimization, but it was not reality unless these technologies which are now helping us to realize this. So that's the step change that we see, and we have several customers where they have moved from where the remote operations used to be only enable services to do proactive or reactive maintenance of your equipments or plants, or even your cooking, or when to do the maintenance of boilers or whatnot, right? And Mr. Hariharan or rest of the people are speaking. But then what it led to is that in today's context is the digital twin concept or model replica of the industries to remotely even configure the whole plant, sitting out virtually out of, and this speeded up our UOP. Did several units like this in the last 1.5 years, even the commissioning that happened. So the remote plant commissioning, plant assisting was able to be possible because of this digital twin concept of validating all your control strategies, even your startup and shut down, so many things that got expedited. And last the resilient operation that I said, from the level 0 to level 5, you see here towards autonomous operation. The resilient operation is all about how today the hardware redundancy is limited to 2 controllers in important places. Right now we are looking at, because of the virtual environment, it has gone to 1 to n. And the control strategies can run at any place. Optimizations cannot run at any place, and they all can be a hive. Where compute is only attaining the compute maximum is the limitation, and nothing else from a hardware perspective, right? So our controllers were branded controllers such as C300, which can host 400 controllers now. Those strategies, it's all virtualized, it's all containerized, so that you allow this whole operation to have this 1 to n resiliency. It's not, the resilient operation is not in the controller or hardware side alone, but also on the operation side. When a machinery has to be taken out and a valve has to be taken out, how do you do? And we are working on certain things around where to make the operations resilient to faults. Still make the maximum out of that. And we have few examples there. Largely the autonomous operation, we have our customers, such as Kairos from Mexico, who has shifted their control room to San Diego, doing completely remote operations. Not many people around for some of the important mining related operations, and the reality of where autonomous operations could exist. Some of the industries are evolving, like the offshore platforms, where you only travel when needed, the safety. So I think I had few more points, but I think I'll pause here. And all these are all possible because of the way we looked at to evolve this whole journey of industrial automation, starting from 1970s till date. Today we have something called Honeywell Forge platform. It is a view of how do you connect all these things, both the sensor data or the derived data from different business applications, and then come up with how do you sustain your peak performance using these platforms. A brief on the Forge platform is given on the right hand side, and I will skip that. And ultimately, it all leads to these technologies. What we have seen is to allow the customers largely go from a capex model to an opex model, which is a very important thing, because you would run at $5,000 servers for a 5% CPU usage, but designed for 100% because of the the number of people that would log in, are all now getting benefited because of this cloud technology, and allowing it allowing this whole thing going from a capex to opex model to leverage these technologies from different angles, and still make it possible to look at the cybersecurity and stuff, other things that typically process industry would really be worried about. And thank you. Yeah, that's it.
Thanks, Dr. Ranga. So I know we are running short on time, so we'll skip. Probably we'll ask for some questions from the audience. Feel free to post them on the Q&A section. We have a first question. The first question is basically how would you rank adoption of Industry 4.0 across different sectors in India and then in developed markets? So I'd probably let Vinayak take that, and then probably subsequently I'll ask Dr. Natarajan to give his perspective.
Sure, thanks, Durjoy. So the way we are looking at the overall manufacturing sector, we've seen that heavy industries or process industries, that's where the adoption is higher as compared to discrete manufacturing. And this is where the concept which Dr. Ranga also spoke about, digital twin, this is very well adopted by companies. And when it comes to discrete manufacturing, whether it's auto industries or FMCG products, there we are seeing that some of the technologies related to IIoT, there the adoption is typically higher. But in terms of the overall spend and in terms of the overall adoption, I think heavy industries, sectors of metals and mining, sectors of cement and building products, these are oil and gas, power and utilities. These are the sectors where the adoption is typically higher.
Perfect. Thanks. And Dr. Natarajan, your thoughts basis?
Yeah. Yeah, what I would say is, because of the nature of our operations, the chemical process industry, there is already there is a high degree of automation. That's where we are in terms of doing this. But we're coming back to the industrial 4, where it is likely to go in some of these industries. What I'm seeing is a movement towards, the physical, cyber, and I would add even biological systems as we move forward in the production systems. And we will be looking at, more and more smarter plants that would respond quicker to changes in the market or changes in the customer trends. In terms of the AI systems, a good point brought out by Dr. Ranganathan is, it's AI is not you just do it once and forget. It's a learning system. So it's kind of, it needs to improve over a period of time. So I'm actually visualizing a system of AI models that will continue to learn, and it's not a single model, it's an ecosystem of models, and that keep a plant in an optimized state all the time. And I'm also thinking, in terms of the maintenance practices, they would also get a lot benefited by this AI things, because you would probably move more towards the preventing type of maintenance, preventative maintenance, because you would be, forecasting problems early and so on. I'm also seeing systems integration at an enterprise level across functions. So, there are no more silos and things operate as a cohesive whole. And finally, I also see that, there would be a greater push towards some of these greener and environmental friendly technologies. And even Industry 4, yesterday I was attending a webinar on sustainability and Industry 4 of AI-based technologies. And so things like that would also be coming in. So that's where I'm seeing a lot of scope.
Sure. Thanks, Dr. Natarajan. So the next question is, what is the extent of cooperation or interaction of Indian industry with that of European industry in adoption of these technologies? Before I come to you, Hariharan, I'll just give you my perspective from what we see at Tiger. We are seeing a lot of demand coming in from global players in order to, embark on this AI journey. Okay, so it's basically at this point of time is there's no systemic things about it, but they are looking forward to more technology and more capability that they can leverage from India. As I see it, when I talk with our, core industry clients across Europe, European region. Would love to hear from you, Hariharan, basis your suite of platforms and products that you have. How are you seeing, some of those things that you assets that you have created being utilized by, organizations in the European market?
Hey, thanks, Durjoy. So this is a very tricky question to answer because incidentally, Motherson is not just an Indian company. It's a global Indian company with bases across the globe. In fact, one of our largest plants is in Germany, and we have a $3 billion company out of that country alone. And therefore, within Europe, we have a huge presence across different countries. And whatever we are building here in India is being taken across to Europe, and not only to the companies within the group, but also to companies outside the group, wherein there is a huge adoption. And I do not see this as a India versus Europe thing. It's more about when we look at, industry 4 per se, right? There is a standard, right? I mean, there is a standard sort of issues that the entire industry is facing, which Vinayak already brought about in his discussion earlier. And we need to look at the means to enable, these problems to be resolved. And when we talk about Industry 4 solutions coming out of digital, it is a set of digital technologies which are aiming to fulfill specific use cases. Could be preventive maintenance, could be predictive maintenance, could be how to, optimize spends, reduce, the overall cost in different aspects of the business. So all these have to be collectively done and not, country by country.
Yeah.
So whatever we create in here in India is applicable anywhere in the globe.
Yeah, well, I think that way the Europe and India, that it's coming together, right? It doesn't matter where you build it or where you deploy it. Basically, wherever the capability is, you pretty much take that capability and use it as much as possible. So I know we are short on time. With that, I do have one more question. Let me see if there's something that we can take care.
There are two questions for Mr. Hariharan, in fact.
Okay. So one question is basically, for Hariharan, the entire system that you have built locally, are you giving these solutions to other companies in India for your expertise? And are you basically, are these digital transformation suite different from other players? So I think that's basically fairly, I would say Madhus and Sumi specific question, but I would let Hariharan answer the first question. So how are you engaging with the Indian clients with your suite of solutions that we have built?
Right. So what I would like to say is we are a manufacturing group. And when we initially started building these solutions, we did not create it with a perspective that we are going to sell it. So we basically created for solving our own problems within the group. And when we started, working on these problems in different regions, like I just said a while back, we saw that the problems are the same in different regions. And we also started interacting with, some of our own partners and, our clients and other businesses as OEMs, etc. And we realized they have similar problems too. And that's when the whole point came about of, starting to take these solutions to market and providing these as solutions to other clients, right? And today we do service not only automotive OEMs, but any kind of manufacturing company across the globe with these same solutions that we build. In fact, we've gone a step further, and for example, solutions like Motif, which are analytics based, except for the manufacturing part, the rest of the things are applicable into any industry. So we're also going cross industry outside the manufacturing space.
Got it. Perfect. Thanks, Hariharan. I think with that, we come to a close. I know we are overshooting the time. I'd let Dr. Joseph, give his parting remarks before we wrap up this session. Over to you, Dr. Joseph.
Thank you, Durjoy, and thanks everyone for joining this panel discussion. The EU-India Chamber of Commerce, right, that we have, EU-India Chambers, the objective is basically to promote the trade between both these geographies, and also to be a facilitator for knowledge sharing, and also for anything that we need to do in terms of policy development and stuff like that, that we need to work on behalf of companies that are not just our members, but also who are doing trade between these two geographies. And this effort of bringing the Industry 4.0 panel discussion is fundamentally to at least to kick off a thought process. And I know many companies are already looking at it, but as we move towards more of new age manufacturing moving into India, and with everything that's happening with COVID and the supply chain disruptions that are happening with China, and a lot of companies looking at setting up manufacturing bases in India, this kind of a new age manufacturing, the likes of what Vinayak has spoken about, the smart manufacturing and smart factory and stuff like that, is going to be very, very ubiquitous going forward. And that's the reason why we thought it's important for us to have a session which actually helps us to think. And I know on this platform today, we have people from the auto industry, the IT industry. I'm just going through the list of people who registered, nanotech firms, pharma industry, people from the academia, people from the energy space, the hospitality space, and the logistics space. It's a fairly multidisciplinary group that's attending this, fairly multi-industry group as well, and people who are founders of companies, people who are from the finance portfolio. We have a completely, a variegated group here. Now, the Industry 4.0 is actually called as the fourth industry revolution. The word that is always used is revolution. But for that revolution to happen, the collaboration between industries, collaboration between functions need to actually evolve. That's why we titled as the evolution of cross-industry collaboration here. And it's a convergence, as Ashank mentioned right at the beginning, convergence not just of technology, not just of the ICT convergence or manufacturing convergence, but it's also convergence with the human body. And that's what was beautifully brought out by Natarajan, right? From how R&D, the application of AI, and then a lot of the stuff even getting integrated into how the human body functions, right? So it's a lot more. In fact, Pierre Nanton, the former chairman of Accenture, said this: 50% of the companies in the Fortune 500 list are no longer there because of digital. Which means what replaced them actually came in because of digital. And as we go along, we'll actually find that many companies which exist today will cease to exist because of Industry 4.0. It's a point for us to think about. It's a point for us to possibly mull over it. And I would really encourage to keep this dialogue going on. I would really encourage to participate in sessions like this. And if you're not a member of the chambers, do sign up as a member, because we will be having interactive forums like this. And our only objective as chambers is to really facilitate this whole transition that India is going through the Make in India movement that we are having. And in that journey, the new age manufacturing happening here, trade happening with Europe and other geographies, and technology transfer coming in here. There's a lot that's going to happen in terms of an action. So that's the whole object of having this. It's a lot more. In fact, when I did a search on quotes for Industry 4.0, you would be surprised. You can go back and check. Most of the quotes there are all from presidents and prime ministers of countries, and from folks from the World Economic Forum. And they're worried about what will happen to jobs with Industry 4.0. They're worried about what kind of jobs will come up with Industry 4.0. So what we're dealing with today is a huge elephant in itself. And I hope that we were able to at least peel a little bit of that onion here today. And this journey will go on. And I really want to thank the panelists who have given their time and brought in this multiple perspectives from consulting, from manufacturing, from R&D to platform. So Vinayak, Hari, Dr. Natarajan, and Ranga, thank you so much for your time today and adding such valuable perspectives in this panel discussion. Thank you, Durjoy, for facilitating this. So ladies and gentlemen, on that note, it's a sign off from us. Thank you for joining in, and be in touch with the chambers. And if your company is not a member, do sign up. You can find out more details on the website. Thanks a lot. Have a great week.
Thank you.
Thank you to everyone.
Thank you.
Thank you. Good day.
Thanks. Thank you.